Back.
Yeah. Hope you guys are liking the whole video thing and doing activities in class, and we've heard from a lot of you that you do like it, so that's good. Hopefully it's helping in your learning.
Hopefully we got some snow.
Yeah.
All right, here we go. So we're starting out with the chapter 6.1 here, and we're going to be looking at ratios, guys, and some proportions. So we're going to kind of be comparing some things in this chapter, starting off with some triangles, and then maybe getting a little bit more complex from there. Or
yeah, actually we develop into triangles because the whole chapter title is similarity in triangles. So back in chapter 4, which was probably our most difficult chapter, we were talking about congruent triangles. Now we're talking about similar triangles. So that's what we're trying to build to here.
Yeah, so just try to keep in your mind, you're looking at two things that look pretty close to the same, but maybe one's just bigger than the other by a little bit.
Right.
Okay, so we're going to start off with some ratios. So 6.1 is ratios. All right, so when we talk about ratios, guys, always remember that we can write those in 3 ways, and those 3 ways typically are A to B, okay, or the word A with the word 2B in there, or as a fraction A over B. Okay, so those are the 3 ways you're going to see ratios done throughout this chapter. Now, when you do ratios, one of the things you got to remember is you have to have the same units. Meaning, if you start out with a problem that's talking centimeters and meters, you've got to balance that out by changing either the centimeters to meters also, or the meters or the centimeters or the meters into centimeters. So that way things always have to be balanced. If you're talking about pounds and ounces, you got to either change them both to ounces or both to pounds. So you always got to be on the same playing field. Okay, so make sure those units are always the same. You'll see more of that as we go. And then always reduce, like any other fraction, guys. A ratio is just a fraction. We always want to try to reduce things because sometimes things may be equivalent but look a little bit different. If you don't reduce, you're not going to see that. So, remember to reduce. Always reduce fractions. That's kind of the golden rule with them.
So let's take a look at an example of that. So let's say that we have this triangle here, and so triangle ABC, we've got the 3 sides marked in here as being of length 5, 10, and 12. And the question here is saying find the ratio of AC to AB. So again, a ratio is just a comparison. We're just comparing 2 things. And so in this particular case, we're comparing side AC, which is the 12, to side AB. Okay? And so as we do that, we would just put them 12 to 10. It's the bottom of the triangle compared to the left-hand side over there, so 12 to 10. But, as Mr. Badilla was just saying, even though we wrote that with the colon in between to show the ratio, it's actually a fraction. And so because it's a fraction and because it's capable of being reduced, we have to reduce it. So it reduces to 6 to 5. 2 went into both the 12 and 10, 6 times and 5 times, so it reduces to 6 to 5. Okay? Another example here with what Mr. Badilla was just saying with the units. So let's say that we were comparing in a ratio 3 pounds to 10 ounces. Now, just as he was saying, we have to convert these both to the same unit. And typically you always go to the smaller unit because it would be hard to write 10 ounces. It would be a fraction. So then you'd have a fraction inside of a fraction. That would just be too complicated. So we typically want to go to the smaller unit. So ounces is smaller than pounds, and so we want to convert the pounds to ounces and then go from there. So hopefully you know your American system here of all these, how complicated our system is of everything, but it's not like the metric system where everything's in tens. There's 16 ounces to a pound, so you just have to know that. If you don't know that, Google it, I guess, like you do everything else. So, so there's 16 ounces to a pound, and so 3 pounds would be 48 ounces, and then the 10 ounces are on the bottom. But again, fraction that can be reduced, so you have to reduce it. And so we reduce that down, 2 goes into both, and so we go to 24 to 5. So the way that 3 pounds relates to 10 ounces is 24 to 5 as a reduced ratio.
And Mr. Scritchfield, I've noticed that on these previous 2 that they had the larger unit on top both times. Like when we did AC to AB, it was 12 to 10, and then we just did 3 pounds to 10 ounces.
That's true.
It was 48 over 10. Is it always going to be the bigger one on top and the smaller one on the bottom?
No, no rule there. It's just comparing one side to the other. But that brings up a good point because order in a ratio is critical. Okay, critical.
Now, Mr. Scritchfield, I know some of the kids are going to ask too, should they reduce 24 over 5 to a mixed number?
No, we want to leave it as a ratio. Yeah, if it's written as a mixed number, we won't recognize it as a ratio.
Yeah,
so don't be a number.
So don't take it too far, guys. Just reduce it, but keep it as a fraction, but don't change it to a mixed number.
Yeah, yeah, good point. Yep.
All right.
Okay.
All right, so segment ratios. This one is sometimes a little bit tricky for kids because you gotta realize what it's saying here and then put everything together. So if you look at this one here, it says if the ratio of AC to CE is 2 to 5, then we got to find the ratio of AC and CE if AE is 28. So notice they got the ratio is basically part to part, okay? Mm-hmm. And so then it goes, okay, well, what's part to part if the whole is 28? So when you set this up, okay, we really don't know what AC is, so we're going to call that 2x. We know it's 2 to 5 with CE, but we don't know that length, so we're going to pop that x in there. And then we have CE, which is 5, so we're going to call that 5x. Now, that's part to part, okay? And then the whole is 28, so all we do is make an equation of, whoops, let's rewind here. We'd make an equation of, let me get this bad boy up here.
There we go.
2x plus 5x equals 28. Okay, now I know you guys already saw the answer is 4, but we're going to fix that. So then you get 7x equals 28. And then, you know, what times 7 makes 28? Well, then that's exactly what it was up there, and it's x equals 4. Okay, now, let me go back here. Now, 4 is not the answer, okay? Remember that. They wanted to know what AC was and CE, so remember, that's where you got to go back and plug it in. So 2 times 4 is 8, and 5 times 4 is 20. So when they have that segment ratio, you just got to look at the pieces and then just try to figure out, all right, what are they giving me? And what don't I have, and how can I put it all together to figure this out? You got anything, Mr. Scritchfield?
No, these are probably the hardest problems out of this section, and we see these problems on CST tests, SAT tests, ELM tests, getting ready for college. These questions kind of show up a lot, and so you just need to make sure that you understand that throwing in the variable thing into that ratio and then setting it up equal to the total. So,
okay. And then we have extended ratio, and extended ratio basically means that we're going from just 2 to 3 or 4 right. or whatever it happens to be. So it's not really a different thing altogether, guys. It's just instead of having 2 pieces, okay, or comparing 2 things, now we're comparing 3 things because how many angles are there in a triangle? There's 3, okay? So key thing to remember here, well, let's read the question. Extended ratios. The angles of a triangle are in the ratio of 3, 5, 10. Find the 3 angles. The key to remember here, guys, is what degrees are all triangles bound to, and it's 180 degrees. So if we think back to what we did right up above there, well, we went part plus part equals the whole, okay? Well, now it's part plus part plus part equals 180 because we know that a triangle has 180 degrees. So we've got 3x plus 5x plus 10x, that's angle 1 ratio, angle 2 ratio to angle 3 is the ratio, equals 180 degrees, okay, which gives you 18x equals 180. And you divide 180 by 18 and you get 10. And remember, they wanted the angles, not x, so go back, plug those in. 3 times 10 is 30, 5 times 10 is 50, and 10 times 10 is 100. Anything you'd like to add there, Mrs. Scritchfield?
Nope.
Okay.
Nope. All right. Okay, so now we have to remember something. Well, you should have done it multiple times in Algebra 1, but you should have started doing it in 8th grade math, maybe even before that. But solving proportions. Now, it'd be good if you knew what a proportion was. So far we've talked about ratios. If we take 2 ratios and set them equal to each other, that's called a proportion. So you need to remember that from Algebra 1. So if we have 2 ratios equal to each other, it's a proportion. And the way we solve it is to cross multiply. Okay, and if one of them has more than one term within that numerator or denominator, then you need to distribute through there. Okay, and then we just set them equal to each other, and then solve. So as in this example here, we're looking at the 4 and 5 being circled there, and so you need to multiply those 2 together, and then the 1 plus 3b and the 2, you would cross multiply those and multiply those together. Okay, and so as we look at that example, and it's not real critical which one you call which, we just want you to see these names, these terms, vocabulary terms, called the means and the extremes. Okay, and so as we do this cross multiplication, one of those products is called the extremes. The other product is called the means. Okay, so the product of the extremes is equal to the product of the means. Is all that's saying. Okay, not real critical. We don't use those terms a lot. We just want you to know that you've seen those before. Okay, so if we distribute that 2 through that numerator, we're going to get 2 plus 6b, the 2 times the 1 plus 3b, and then the 4 times the 5 is the 20, and you just set them equal to each other. Doesn't matter which one goes on which side for this. We did have something like that in Algebra 1 where it did matter, but when you're solving a proportion, it doesn't matter which one you put where. Okay? So as we solve that, if we take the 2 to the other side or subtract 2 from both sides and then divide by 6, we get b is 3. Okay? And that's the goal here, is to just solve for the variable.
Now, Mr. Scritchell, I know some of the guys are going to ask, well, could this one here, if I go 4 times 5, could I call that one the extreme, and could I call 2 times 1 plus 3b the mean?
Yeah, it doesn't matter.
Okay.
Yeah, those terms are not real critical for us, especially for what we're doing.
Yeah, exactly. Guys, just remember you just got to cross multiply and then solve. I mean, that's basically what it is. It's just a fancy way of calling it cross multiplication.
Yep. You guys have done this lots of times. This is not going to be real complicated for you. So here's just another example. Now again, they can get a little bit complicated if you know, we've got some kind of more complex algebraic expressions for numerators and denominators, but this one is not too much more complicated than the one we just did. So if we have 2 minus s over 3, and that ratio is set equal to 2s plus 1 over 5 as a ratio, that's called a proportion. To solve a proportion, we cross multiply. So if we cross multiply here, we're going to get 3 times the 2s plus 1. So if we distribute that, we'll get 6s plus 3. Cross multiply the other one, 5 times 2 minus s gives us a 10 minus 5s. So if we add 5s to both sides, subtract 3 from both sides, we're going to end up with s equaling 7 over 11. So this one doesn't come out to a whole number. Again, don't let fractions panic you. That's just a ratio. And so the answer comes out to 7 over 11. And that's okay for right now. All right? Okay. Geometric means. Now, this is an interesting concept here with the geometric mean. What we're trying to find is a geometric mean between two numbers. Okay? In this case, we're talking about, for a general example, we're talking about finding the geometric mean between a and b. Now, you should know how to find the arithmetic mean. Now, maybe you don't know that term. It would be good if you knew that term, but maybe you don't know it by that term. Finding the mean or the arithmetic mean is the same thing as finding the average. So remember, to find the average of two numbers, you add them together and divide by how many there are, 2. Okay? So to find the geometric mean, this is probably the first time you've seen geometric mean, we just step those operations up one level. Okay? So instead of adding the numbers together, now we multiply them together. Instead of dividing by 2, we take the second root or the square root of that product. Okay? So, as it says here, the geometric mean of two numbers, a and b, is the square root of a times b. Okay? Called the geometric mean. Arithmetic mean is the average. The geometric mean is something different. Geometric mean. Okay? And we'll look at examples later of exactly what the geometric mean tells us. Okay? So here's our example here. Find the geometric mean of two specific numbers here, 12 and 27. So just as we said in that example, we're going to multiply those together first and then take the square root of that. So the geometric mean of 12 and 27 is 12 times 27, square root of that. Okay? So if you did that out, that would end up 12 times 27 is 324. Take the square root of it, ends up being 18. Okay? And again, we'll look at examples of what it means to get to that process, but it's basically a specific proportion between these numbers. They end up being in the same ratio, 12 to 18 and 18 to 27, but we'll get to that later. So that's the geometric mean. Okay. So what if we were asked to find the ratio of these two sides? If we have BC to AC, now again, order is critical here. If they tell us that BC to AC is 2 to 3, and they want us to find the length of AC, then we're going to set up this proportion here. So BC to AC is 2 to 3. So we set the 2 to 3 there. The length of BC is 52, so that goes on top because that's the first one in the ratio. The x at the bottom of the triangle goes on the bottom of the fraction, okay, because it's the second one in the ratio. And so there's our proportion. 52 over x is equal to 2 over 3. We're just going to cross multiply. 3 times 52 is equal to 2 times x. And if we divide by 2 on both sides, we'll end up with 78. So that was section 6.1. And we will be seeing you in class tomorrow and working on an activity for this. So
make sure you take good notes.
Yep. We'll see you guys in class.